a confession to make. I used to be a Java developer. And in fact, even worse, I used to be an enterprise Java developer. And for those of you who've known that world of pain, it's a very rigid sort of way of developing. You've got all of these standards that you have to comply with, and you've got all of these technologies that you have to build on top of. So if you're building something as simple as Hello World, it can be layers and layers of complexity. And yeah, it's really constraining as a developer. So one thing, about 10 years ago, I started doing web application development, switched from Java to web. And it was really liberating. It was, I could do whatever I wanted. I could be creative. I could develop things rapidly. I didn't have to worry about all that stuff. And so I admit that I just started just hacking away and just, there were all these libraries and frameworks becoming available as the web kind of matured and web application development matured. And for me, it was like living the dream. There was a smorgasbord of libraries and plugins and things that I could pull in and I could use, and I could build these amazing things, in days. But then, this happened. Basically, my code started to look like this. And I realized, in fact, one of the things that made me realize was I was working on, it was a Firefox extension, and it was for researchers to, it was actually a semantic web application to allow them to draw in all these different bits of data, and it was all using metadata, and it was all kind of very structured. But the code that was behind it was awful. And it was open source, and I was trying to get people to collaborate with me. And in fact, we were going through the Firefox review process at the time, and I was getting feedback from the reviewers, and it was kind of like, well, why am I writing code like this? There is actually a good reason for all of that, those layers of standards and those specs that we had to follow in the Java world. So how can we do that in JavaScript? Given that the JavaScript language doesn't really have native support for that kind of modularity that is built into the frameworks like OSGI and so forth in Java. And some of the reasons for building modular web applications, well, they're pretty obvious. They're things that they've been drilled into us when we learnt programming or when we studied software engineering, and they're all really important things, but we tend to forget them sometimes, or maybe it's just too hard or we get too excited about the code. So things like namespacing, separation of concerns. So really talking about that Unixy model of having small components that do one thing really well, and then you can compose them flexibly to build bigger applications. And also that this improves the ability to test that code and to maintain that code, and helps to reduce complexity because developers can find it easier to understand each little module and how they all interact. And hopefully then people can reuse those modules. So because we don't have native support in JavaScript, how do we actually do this? And there are really two ways that we can achieve this. One is through patterns, and the other is through using frameworks that kind of provide that functionality for us. So I'm going to talk a little bit about some of the patterns today that exist for developing modular JavaScript applications. And in fact, modules mean many things. It's a very overloaded term in CS. So I'm not going to be talking about modules in the sense of like HTML5 modules where you've got kind of reusable bits of CSS and HTML and JavaScript. I'm just going to be talking about modularity in terms of JavaScript development. So one of the first patterns that I started using when I was kind of getting back on track was just providing namespace support. So I'd kind of littered the global, I was polluting the global namespace with all of these little variables for different functions and variables. So one thing that you can do to avoid that is just to use object literals. And this is what I started doing at first. So basically you create a module, it's just an object literal, and inside of that you declare all of your functions and all of your variables. So if we imagine that we wanted to build a math module for some reason, we could build it like this. So we've got a number of functions, we've got some fields in there, And because of the way that JavaScript doesn't really have modifiers on variables and functions, we don't really get public and private variables and functions in this. So people use conventions like underscore means private. And that kind of works. It works pretty well for small applications. But then people started wanting to be able to actually control access to the visibility of those functions and fields. And that's where the module pattern comes in. And I'm sure everybody here is familiar with the module pattern, but just bear with me. So the module pattern is basically using a function to encapsulate all of those different functions and fields. And you have the ability to return only the functions and fields that you want to be public. So you can have functions and variables inside of the scope of that function, and they won't be exposed outside of that function. So it simulates public and private visibility for those items within the object. And this is achieved through this immediately invoked function expression, which is what you see with the function with the brackets after it. So that works pretty well. There are slight variations on that pattern as well that people have developed over time. So an alternate way of doing that is using this. So you've got your function, so it's your function expression, and you've still got sort of public and private variables and functions inside of that. But instead of sort of returning an object literal that embeds all of the public things, you actually return this. So you're building up the this object with the things that you want to be public. Another pattern that's also a slight variation on this and that's slightly more neat, perhaps, is the revealing module pattern. So again, you have your function expression, and you've got your functions and fields. So we've got, for example, pi and sum and add. And we can actually declare them all in the same way. So we don't have to have some public fields or functions down kind of in a special section. We just declare them all throughout the module, and we can organize things the way we want. And then we just kind of reveal the ones that we want to be public by returning an object literal that kind of maps from to the field names and the function names that we want to our internal functions. And that means that we can actually change the names of them very easily and change which ones are public and private very easily as well. So that's the module pattern. But one of the limitations of that pattern is that when you do have things that you've kind of scoped within that function to make them private, it's hard to extend, if you want to subclass that module. So kind of an additional extension to that pattern is the idea of having privileged functions. So people kind of describe it as privileged fields. It's a little bit like having something that has a visibility where all of the subclasses can see and manipulate that field, but in fact it's the functions that are privileged. So in this case, what we've done is we've got a private field, so my private constant, and we expose that through a public getter and setter method, or function. So that allows us to allow people to override that in submodules, but also to keep some sort of degree of control over that private state. So all of these patterns that we've talked about are really about encapsulation. So there are a bunch of different reasons why we want to write modular code. Encapsulation is one of them because it helps to reduce complexity of the code in the system. But there are some things that these patterns don't address. For example, it's still possible to write very tightly coupled modules using the module pattern. So in order to have that kind of composability, that ability to reuse things in different contexts, we really need to have loosely coupled modules. And a pattern that can help us here is the mediator pattern. So the mediator pattern, a mediator is basically just like the core of your application, and it's the thing that kind of mediates communication between all of the different modules. So rather than one module talking directly to another module or requiring something directly from another module, they use publish subscribe. So the message passing between the mediator and the other modules. So this works pretty well for decoupling the modules, But an improvement on this is to add a facade in between the mediator and the modules. And that facade is basically mapping, it's kind of like providing security to say, which modules can do certain things, and maybe remapping the names and the messages that get passed. So this allows us to build, very loosely coupled modules and reusable modules using the module pattern. But patterns alone are not really enough, because we can write extremely modular kind of code, but then how do people actually reuse that code? So, and the other thing that happens is that there are different frameworks that are providing kind of different syntactic sugar for doing this, because the module pattern's a little bit kind of tedious to do manually. So you do end up with these modular bits of code, but they're all written in different frameworks. And so you can't really reuse them, not without rewriting the code in some way. So in about 2009, a bunch of people started working together on a thing called CommonJS. And the idea behind this was to try to standardize, or at least to get people developing modular code on the same page. And you might be familiar with CommonJS because it's basically what's used in Node.js. So you require modules, and then you have exports where you kind of declare the things that you're exporting in your module. So it's used in Node, and another place where it's used is Browser.fi, which is kind of the ability to take Node code and to package it up for the web. One of the things about CommonJS, though, is that it is synchronous. And this doesn't necessarily work well on the web, where we want kind of asynchronous loading of our modules. So something that came out of the CommonJS community, but eventually split off because there wasn't agreement from everyone in the community about it, was AMD, which is the asynchronous module definition. And this is an API, so it's not actually an implementation, but it's an idea of actually having asynchronous modules rather than just synchronous modules for the web. And it was originally based on the work that had been done in Dojo with Require there, and the way that had worked is they'd used XML HTTP requests to kind of fetch the modules and then use a val to kind of include them, and that wasn't ideal for obvious reasons, a val being pretty evil in that context, and the fact that you'd have to do all of these XML HTTP requests to get all of these different modules, it wasn't the most efficient way of doing things. So the way that AMD does it is that it actually uses function wrapping. One of the main implementations that you're probably familiar with is Require.js, which is used often with Angular. And so the way this works, well, for example, if we need to use some modules, we use require. And so we've wrapped the function. So where we actually want to use that code, we're giving it a function that's only going to happen once those modules are loaded and available. And defining a module is pretty similar kind of a pattern. So we define a module, we give it a name, we have any dependencies for that module, and then we have a function which is actually the thing that implements our module. And so we'd want to return something in that function that exposes the public functions and fields within that module. So that works pretty well, but now we've got kind of two approaches to doing this. And there are some people, if you want to write reusable code modules, you might want them to be able to be used both in Node.js and also other CommonJS implementations for the web, as well as in AMD-based implementations. So the universal module definition kind of arose in response to that. And this is a way of writing modules that work with AMD and CommonJS, and also just with your standard browser globals. But as you can see, it's a little bit complicated, and you wouldn't have to do this every time you were writing a module. So at the moment, I'd kind of recommend that if you are writing a library that you really, really want to use across all these platforms, that you do look at UMD, but otherwise just choose one. Choose AMD or choose CommonJS, depending on what suits your particular use, and stick with that. So yeah, there is a great deal of fragmentation. So I haven't talked about all of the different approaches that are available through other frameworks, but if you look at, say, XJS, Dojo, Require.js, they've all got their own kind of syntax for this. And so at the moment, if you are trying to write modular JavaScript, you're kind of left wondering, well, what should I do? And pretty much you just have to go with whatever framework you're using on your project and just write your module for that, and then realize that you might have to transpile it or you might have to rewrite it for another module system. But the future is brighter than that. So we're kind of in a transitionary period at the moment. But there is actually work being done with ECMAScript 6 modules. So this is the standards group that works on ECMAScript, which is the standard behind JavaScript and behind things like ActionScript. And they're actually looking at adding support for modules to ECMAScript itself. Now, they've been inspired by the work that's been done on CommonJS and on AMD, but they haven't actually adopted either one of those. They've actually come up with their own approach. And this is the way that you do it. So you specify a module, you give it a name, and you export functions and variables within that module. And then there's several ways that you can use, there's quite a few ways you can use those modules. So you can import specific things. So for example, if we just wanted to import the add function and pi constant from our module, we could do that with an import statement, and then we just give them kind of local names and we use those names. Or we could import the entire module into a namespace, so math, for example, and then we just use that. We prefix wherever we want to use that with that namespace. So, yeah, I guess at the moment there is a lot of fragmentation. It's kind of difficult to know what to do. But if you do want to use the ES6 modules and kind of move towards the future, you can. There are 2 transpilers available, which will let you take existing AMD modules or existing CommonJS modules and translate them into ES6 modules. So there's one from Google, which is called Transeur, and there's another one from Square. And there's also polyfills available so that you can use it in the browser today. But the problem is that it's a standard that's still very much under development. It is likely to change quite a bit. So if you do start using ES6 modules, be aware that you might have to change the way that you implement your modules over time. But yeah, modularity, really important. And I'm glad that it's actually being added to the language. So thank you.